are watching Darasa Online.
It's Darasa Online. My name is Mbarak Omar Abed, teaching advanced mathematics. To all students, you are most welcome. Join my session from the beginning until the end of the session. Still, we are continuing with our revision on probability, but today we are going to focus on special probability. Under special probability, you need to revise on binomial probability distribution, Poisson probability distribution, and a normal probability distribution. But for this session, we will revise only in two: binomial probability distribution and the Poisson probability distribution. Now, why binomial probability distribution? Because dealing with the counting. As you remember, when we are starting in the first lesson or second lesson, we mentioned some topics that are to be covered. Among them was counting. Counting dealing with combination and permutation. So binomial probability distribution make use of combination. So we are going to employ it in our discussion or in our revision concerning binomial probability distribution. But before we go and check some examples, let's revise ourselves on the characteristics of binomial probability distribution. So our lesson is advanced mathematics. So our focus for today, as I said, is binomial probability distribution. In binomial probability distribution, we have some characteristics that you need to understand or to remember. I'm sure you have gone with them in normal classes. Binomial probability distribution, it has three characteristics. Number one, there must be many independent trials. What do you mean by saying many independent trials? So the number of trying, or when you are doing experiment, they're supposed to be many. The second one, in every trial must have two outcomes. The outcome are success and the failure. When you say success, means the one that you are looking for. When you say failure, it's the opposite of success. Lastly, probability of success is constant from trial to trial. Or we simply say the probability of success is constant throughout the experiment. Probability of binomial distribution is given by the formula. So we have the formula for probability distribution. And that formula is written as probability of xc given variable xc equal to n c xc, then p to power of xc q n minus x. Now this is the formula for finding probability under binomial distribution. But what is c stand for, p and q stand for? We need to know. So whereby c stand for combination. We learn this one when we are dealing with counting. But we have also letter P. Letter P, this is the probability of success. The one that we said it is constant throughout the experiment. And the Q, this is the probability of failure. But if you remember, if you take the probability of event to occur and not to occur, we always get 1. So P is the same as probability of event to occur, and the Q, probability of event not to occur. So if we add the two, P plus Q, here we get equal to 1. So using this formula, if you are given probability to occur or probability of success, to obtain Q is the same as taking 1 minus P. So it depends on the given question. After that, we need also to know, I said this C standing for combination. We have this term here, NCX, meaning that this is N is standing for number of trial, and C standing for combination, where X is taken from this number of trial, which are many, as I said in the beginning of my lesson. So this one is given by the formula N factorial divided by N minus XC factorial to the XC factorial. Now, from the formula, N standing for the number of trial, N equal to number of trial, and XC, this is the random variable. And where XC is normally picked from this number of trial. So after going through the characteristics of binomial distribution, now let's now start checking example number 1 on how to use the formula of binomial probability distribution, which is NC of XC, probability of success to power of XC, probability of failure to the power of N minus X. So my dear, so let's go together checking the first example until the end of our session. Okay, example number 1. If a fair coin is tossed 4 times, what will be the probability of getting at least 3 tails? My dear, so you need to remember again, when we say a fair coin, it means a coin that is normal, having a tail and a head. So this coin is tossed 4 times. So the number of trial is 4, according to the question. Now let's draw data from our question. Now the part of solution, we are given a coin. Remember, a coin has 2 faces, a head and a tail. So if you find the sample space of the number of elements containing in a coin, S is head and tail, in which when you find probability of H and that of tail will be 1/2 and 1/2. But remember, here under binomial distribution, we are talking about P and Q, where P is the probability of success, or the one that you are looking for, and Q, the probability of failure. Now, this is a fair coin that is tossed 4 times. So number of trial, we are given N equal to 4. What will be the probability of getting at least 3 tail? You need to know again the meaning of at least. At least means greater than or equal to 3. So that is tail greater than or equal to 3. This is what we are looking for. We are given number of trial as 4. Our question is asking probability of obtaining at least 3 tail. Now, what is P and what is Q when you are using a fair coin? P will be equal to 1/2, and the Q will also be equal to 1/2. Now it's time to rewrite the formula for finding probability. So probability of tail greater than 3. This is obtained by taking probability when tail equal to 3, we plus when probability tail equal to 4, because we are given number of trial which is 4 times. Now the formula, it will be tail equal to, we are given number of trial. Now instead of using x, we are going to use t. Let's use small t to avoid the confusion. Then p raised to t and q raised to n minus t. That is the formula for finding probability distribution under binomial distribution. Now it's time to plug. So our n is 4, so it is 4 combination. Our first t is 3, so writing 3. P is 1 over 2. Raised to t, our t is 3. Again, q is 1 over 2. Raised to n minus t, our n minus t is 4 minus 3, which gives us 1. Then we plus. Probability when tail equal to 4. So it is 4 combination 4, 1 over 2 to power of 4, and 1 over 2 to power of 0, which is normally equal to 1. Now from there, take your calculator, plug and simplify. 4 combination 3 is equal to 4, So 1 over 2 to 1 over 2 the same as taking 1 over 2 to the power of 4, which is equal to 1 over 16. 1 over 16 times 4, we get 4 over 16 plus 4 combination 4. Now let's check that one again. 4 combination 4. 4 combination 4. This one is equal to 1. So we plus 1. But we have 1 over 2 to power of 4. But times 1 over 2, I said this is equal to 1, which is 1 over 16. So adding the 2, you will get 4 plus 1 is 5 over 16. Now use your calculator to divide. 5 divided by 16, we get 0.3125. So probability of obtaining at least 3 tail is equal to 0.3125. That is example number 1. This is when you are given a fair coin. Now let's check second example. In our second example, we are given a coin is biased in such a way that the probability of getting a tail is 1 over 4. If the coin is tossed 6 times, find the probability of getting at least 2 tail. So the first example was a fair coin, but this one is a biased one. When we say biased, it means not normal coin. That's why we have a probability of getting 1 over 4. As you know, a coin has a probability of 1 over 2 for each outcome to appear or to occur. But this one has 1 over 4. A coin is biased. When you see this bias, it means it is not a normal coin. Now, how are we going to solve such kind of question? My dear student, let's go together. So you need to know some terminology that are used when questions are constructed, like that one. In the first example, we see just normal coin, but in the second example, it is a biased one, means not normal coin. A coin is biased in such a way that the probability of getting tail, so we have probability of getting tail, and that one will be the probability of success, because the question is asking about tail. So probability of success, P, will be equal to 1 over 4. But we are given the number of trial. It was tossed 6 times. And we asked to find probability of getting at least 2 tail. So this is our question. But check here, our n is 6. It's the same as finding probability of tail greater than or equal to 2. It's the same as finding probability when t equal to 2, probability when t equal to 3, plus probability when t equal to 4, probability of t equal to 5, and the last one, t equal to 6. Or you may change into other way. That is, probability of t greater than or equal to 2 is obtained by taking 1 minus probability of t less than 2, in which we are not taking 2 here. We'll be using 1 minus the probability when t equal to 0 plus probability when t equal to 1. All these are used to find the probability. But remember, when you're in exam, you'll be going with time. Now, for saving time, I advise you to go with the second method or the second option. Okay. Now, but in the formula of finding probability under binomial, we have n combination t, p to power of t, q n minus t. We still have to find what is q. So as we can substitute in our formula and then simplify. But remember, if you take probability of success, that one of failure, this is equal to 1. Now, what is p? Our p is 1 over 4 plus q is equal to 1. So q will be equal to 1 minus 1 over 4, which is equal to 3 over 4. That is the value of q, which is supposed to be substituted in our formula. As I said, we are going to use the second option. So probability when tail is greater than or equal to 2 will be equal to 1 minus. Now, probability when t equal to 0, it means our n is 6, combination 0, p, our p is 1 over 4. So it is 1 over 4 to the power of 0, then 3 over 4 to the power of n minus t, 6 minus 0, which is 6. Then we plus, when t equal to 1, so it is 6 combination 1, 1 over 4 to power of 1, 3 over 4 to the power of 5, because we are doing subtraction n minus t. Now thereafter, just simplify and write your solution. Write your final answer. So let's proceed. Probability greater than 2 will be equal to 1 minus. Now using calculator, finding 60 combination 0, 60 combination 0 is always equal to 1. So it is 1 over 4 power 0 is also equal to 1. We have 3 over 4 to power of 6. We plus 60 combination 1. So again, use your calculator, take 60 combination 1. You get 6. So it is 6, 1 over 4 to the power of 3 over 4 raised to 5. Let's simplify the inner bracket, then we minus by 1. So it is 1. Let's go together, take your calculator. We are taking 3 over 4, then put it power 6. Three over 4 to power of 6 is 729 divided by 4096 plus 6 Now multiply by 1 over 4 times 3 over 4 to power of 5. Again, taking 3 over 4 to the power of 5, then multiply by 1 over 4, multiply by 1 over 4, result into 2, 4, 3, 4, 0, 90, 96. Now, when you multiply, you will get the following. So 729 plus 6 times 243, we get 1,458 divided by 4,096. Now adding, then simplify. 729 plus 1458 divided by 4096. So you have 1 minus 0.5339. Lastly, when you take 1 minus 0.5339, the last solution is 0.461. So that is probability of getting at least 2 tail, my dear student. Hope we are together. Okay, now let's see example number 3. We have a question. An underground mine has 5 pumps installed for pumping out storm water. The probability of any one of the pump failing during the storm is 1 over 8. So automatically you see, when you see failing, it means that is not to occur. This is the probability of failure, the Q1 in the formula for the binomial distribution. What is the probability that at least 2 pumps will be working and all pumps will be working during a particular storm? Now let's check solution on how to solve that question. Now, solution. We are given 5 pumps, so that is the number of pumps. So this is n equal to 5. Again, in the statement, there is a part saying probability of any one of the pump failing. So this is Q, the probability of failure, equal to 1 over 8. Then how are you supposed to find the P? Hope you remember. The same as taking 1 minus the Q. So it is 1 minus 1 over 8, which is equal to 7 over 8. So probability of success is 7 over 8, my dear student. Now, part A, at least 2 pumps will be working. Again, what the meaning of at least means greater than or equal to 2. Find the probability of at least 2 pumps when x equal to pump. But our question is x greater than 2, greater than or equal to 2. This is what we are looking for. Again, go back to the formula and look what are the needs. So the needs of the formula is you need to have n x p to power of x q n minus x. We have all of them. We have n, which is 6, which is 5. Our x now depend. We are given x greater than or equal to 2. Now, to find the probability of x greater than or equal to 2, it's the same as taking 1 minus probability of x less than 2. 1 minus probability when x equal to 0 plus probability when x equal to 1. we have our n is 5, x, we have 0 and 1 as per our formula. Instead of using probability of x greater than or equal to 2, we are going to use 1 minus probability of x less than 2. Also, our p is 7 over 8, q is 1 over 8. For just reminding you. Now, probability x greater than or equal to 2 will be equal to 1 minus. Now, let's go direct because we know the formula. Our n is 5. So it's 5 combination. We are starting with when equal to 0. Our p is 7 over 8 to the power of 0, then 1 over 80 to the power of n minus 5 minus 0, which is 5. We plus when x equal to 1. So it is 5 combination 1, p over 8 to the power of 1, 1 over 80 to the power of 4. Then use your calculator, simplify. So you have 1 minus 5 combination 0, 5 combination 0, 5 combination 0 is just 1. So right here, 1. You have 7 over 8 power 0. This is equal to 1. So you remain with 1 over 80 to power of 5. So it is 1 over 8 to the power of 5. So the answer here is 1 over 32,768. Then plus 5 combination 1. 5 combination 1. 5 combination 1 is 5. 7 over 8. 1 over 8 to power of 4 again. 1 over 8 to power of 4 is 1 over 4, then multiply by 7 over 8. We have 7 over 32,768. But here we have 5 times 7. So it is 1 minus 1 over 32,768 plus 5 times 7 is 35 divided by 32,768. So if you simplify to the last point, it is 1 minus. So 1 and plus 35 is 36. So take 36 divided by 32,768. We get 0.0010986. So when you subtract with 1, you'll ending having 0.9989. So that is the probability of getting at least 2 pumps that will be working as in part A. Let's check part B. In part B, we are asked to find when all pumps are working, what will be the probability? So all pump working, it means the same as taking when x equal to 5. Remember, this x represents the number of pumps that are installed in underground. So when x equal to 5, what will be the probability? Go back to the formula and then substitute. So the formula is n combination x, p to power of x, q n minus x. So our n is 5 to combination 5. Our p is, if you remember, is 7 over 8 to power of 5. Then it is 1 over 80. 5 minus 5 is equal to 0. So this one is the same as writing 1. So lastly is 5 combination 5. 7 over 80 to the power of 5. So my dear student, use again your calculator finding 5 combination 5. So 5 combination 5, this is equal to 1. Multiply by 7 over 8 to the power of 5. So 7 over 8 to the power of 5. This gives 0.512908. So when you multiply with 1, you get 0.51291. So that is when all pumps are working. The same as writing probability of X when equal to 5. According to the question, all pumps will be working during a particular storm. Now, after that example, now let's tune into Poisson probability distribution. As I said when I was opening the session, we'll be discussing on probability under binomial. Second will be on Poisson probability. So Poisson probability distribution, it also takes all properties, all characteristics of binomial probability distribution. It means all the 3 properties that are under binomial probability distribution are also applied in Poisson probability distribution, my dear student. But we have another one. There must be an interval of time. It means here the trial will be in terms of time, like per second, per minute, per hour, and so on, per week, per year. And the formula for Poisson distribution is given by P bracket of X equal to X Now the formula is probability of X equal to, we have lambda to the power of X, then times E to the power of E of lambda divided by X factorial. But what is lambda? You need to know. And what is E? E is just the exponential function. Exponential function. And lambda, this is the mean of the given trial. And this one represents X factorial. Now, under Poisson probability distribution, mean, variance of the data, these are always equal. But finding standard deviation, normally we take the root of variance. Variance. As I said, mean equal to variance equal to lambda. That is under Poisson probability distribution. So therefore, standard deviation will be equal to the root of. You may be asked the question to find the standard deviation, my dear student. Now let's check a simple example here before we continue checking complicated example. You may be given a question, find probability of X equal to 5. You may be given a question like this, find the probability when X equal to 5 in which X follow PO then 2. Like that one in examination, you think it's very easy. If you fail to remember the formula, my dear student, you will never get this question. Now, this one is the same as writing the mean. So 2 is our mean. Now let's go to the formula. The formula is P of x equal to x is given by lambda, which is our mean, to the power of x, e to the power of negative lambda divided by x factorial. Our x here is 5, but you are given mean of 2. So therefore, probability of x equal to 5 will be equal to, now the lambda, our lambda is 2. So it is 2 to the power of x. Our x is 5. So power 5 times e to the power of lambda. Our lambda is 2 divided by x, which is 5. So it is 5 factorial. So you can simplify and write it 2 to power 5, 5 factorial, then times 1 over e square. From there, use your calculator, simplify. So when using calculator, 2 power 5 is 32 divided by 5 factorial. 5 factorial is 120 times 1 over e square. 1 over e square is 0.13534. Then let's simplify. 32 divided by 120 is 0.266 multiplied by 0.13534. So you'll get 9.424 times 10 to the power negative 3, which may simply be written as probability of x equal to 0.00944. So that is how to find probability when given x equal to 5, x follow Poisson of 2. That one is a simple example. Now let's check example number 1 on Poisson distribution. One machine technician is attached permanently with a shop. In every hour, he seeks an assistance if a machine causes an average of 2 breakdowns per hour. Find the probability of more than 2 breakdowns. That is part A. Part B, the probability of at least 3 breakdowns. Now, if you see the question, you are given only one data, which is 2 breakdowns. And this is the mean of the breakdowns. So solution of that question. So if you look clear, you'll be having mean, which is 2 breakdown per hour. As I said, in Poisson, there must be an interval of time. Part A, find the probability that more than 2 breakdowns. So probability. So we are let x stand for the number of breakdown. So it is x. More than means greater than 2. That is the question. But from Poisson, probability of x equal to x is given by lambda to the power of x, e to the power of negative lambda divided by x factorial. But here we have greater than 2. Also, you can use, instead of saying greater than 2, we can tune into x greater than 2 equal to probability 1 minus probability of x less than or equal to 1. So as we can simplify, so it's equal to 1 minus. So here is probability when x equal to 0 and the probability when x equal to 1. Thereafter, let's go right to our formula and substitute. So it is 1 minus. So probability of x, remember, we have our lambda. Our lambda is 2. So we have 2 to power of x. Our x is 0 times. The expectation is e to the power of 2 divided by 0 x. Our x is 0, so 0 factorial. We plus, when x now equal to 1, it will be 2 to the power of 1, again e to negative 2 divided by 1 factorial. From there, it's very easy. But you need to remember, what is 0 factorial, my dear student? 0 factorial is equal to 1. So what remains here is 1 minus 2 power 0 is also equal to 1. So here we'll be having e power negative 2 plus 2 times e to power of negative 2. Now let's simplify the inner, because here we have 1 and here we have 2, the same as taking 1 minus 3 e to the power of negative 2. Let's use a calculator. So 3 times e to the power of negative 2. And that gives us 1 minus 0.406. So using again calculator, minus 1. So it is 0.59399. So that is probability of getting more than 2 breakdown. My dear student, hope we are together to that point. Let's check part B of the question. Part B of the question, at least 3 breakdown. Again, we have a term, at least. Remember again the meaning of at least. At least means greater than or equal to 2. Remember in the first part of the solution, we said we let x as the number of breakdown. So greater than 3 equal to, again tune to this form, 1 minus probability of x less than 3. The meaning of that is 1 minus to the bracket of, when the probability of x equal to 0, probability of x equal to 1, probability of x equal to 2. So we exclude 3 because of less than 3. Thereafter, let's go to the formula. 1 minus. Our formula, remember, it need you, the formula is this one. Lambda to the power of x times e to the power of lambda divided by x factorial. Our lambda is 2. To the power of x, we are starting with this one, power 0. Then e to the power of lambda negative 2 divided by 0 factorial. We plus when it is 1. So it is 2 to power of 1 e to power of negative 2 divided by 1 factorial. We plus the next one, 2 to the power of 2 times e to the power of negative 2 divided by 2 factorial. What next is to simplify. 0 factorial is equal to 1. 2 power 0 is equal to 1. So it is 1 minus, here we have e power negative 2 plus 2 power 1 is 2. So it is 2 e power negative 2 plus 2 power 2 is 4. But what is 2 factorial? 2 factorial is equal to 2. So 4 divided by 2 is equal to 2e to the power of negative 2. Then from there, keep on simplifying. and then you're about to finish the question. So we have 1 minus, if you check here, e power 2, 2e power 2 plus 2e power 2, all are the same. So we're adding 1 plus 2, we get 5e to the power of negative 2. Use your calculator, find 1 minus 5e to the power of negative 2. So we'll get 0.3232. So that is the probability of getting at least 3 breakdown in the question. Now, due to time, this now is a question for you as a take-home assignment for more practice. As you know, always practice makes perfect. If you find a question like this one, the probability of defective item is produced by a machine is 2.5%. Find the probability of obtaining fewer than 3 defective items in a random variable of 100 items. How am I supposed to go to the solution? No problem, my dear student. Now, check the tips on how to solve this question. I'm not going to do it. This is your assignment. Okay? Now, to do it, you need to know the concept of Poisson probability approximation to binomial probability distribution. So that question is failing on this part. Now, condition for approximation of Poisson to binomial. First, the number of trial is larger. Example, number greater than or equal to 30. But in our question, the number of trial is 100. Okay, now this is failing in this condition. So condition number 1 is okay. Number 2, probability of an event or outcome is small. Probability of success less than 0.1. So if you change, you are given, remember, 2.5%. Changing 2.5%, it will give you 0.025, and that is also less than 0.1. So you can go directly and use this approximation that x follow binomial distribution of n to p, where n is the number of trial that is given in the question, and p is the probability that is given also in the question. Then x follow Poisson n p, where n you know it, which is 100, and p is 0.025. Thereafter, you go and use Poisson formula. You conclude by giving the answer. To that point, I end up my session, so don't miss the next lesson.